All right, we are on 1-2, day 1 of 2. All right, little geometry review. Okay, I'm going to go another one here. I'll go with that. Okay, naming lines, segments, and rays. Should be pretty straightforward. How do you name a line correctly? How should I name this line, or could I name this line, I should say? Jimmer.
Line AC.
Line AC. So AC, and how do I make it line AC? Go ahead.
Just put the arrow over top.
Okay, can I flip the letters around? CA. Is that legal? Could I have used B in there? Well, in other words, what's the rule for naming lines again? What do you have to have here? Go ahead. Any 2 points with the line symbol. Okay? Segments. How many segments do you see in this picture? If you see any, how do you name them? Adam, what do you got?
You just put the bar on top.
You just put the bar on top, and what's underneath the bar?
It'd just be like A.
Yeah. So segment AB. So we're talking about the set of points that starts at A, stops at B, little bar symbol. Are there any more segments in that picture? Yep. BC. Starts at B, stops at C. Any more segments in the picture? Yep.
AC.
AC. Okay. So we got segments. Segments have a finite length. You can measure it. Lines go on forever. And then rays. What do rays do? Adam?
They go off in
One
one direction.
direction forever. So tell me some different rays you see in this picture. Anybody? Name a ray. Yes. Ray AC. AC. What's the ray symbol look like again?
1/2. Left side, nothing, right side, 0.
Yep. The ray symbol, when you name it, always points this way. So this is saying your ray starts at point A, goes to C, and then keeps going. Starts at A, goes to C, keeps going. Shoots in that one direction forever. Do you see any other rays in this picture? Adam? BC. Starts at B, goes to C, and keeps going. Any other rays? There are. Exactly 2 more. Yep. What'd you say? BA. Starts at B, goes to A, and keeps going. And the last one in here? Emma? CA. Starts at C, goes to A, and keeps going. Could I have called that one CB, remember? C to B and keep going? Okay, so those are rays. All right, we are moving into angles. And you're familiar with angles. You measured them in geometry with your little protractor. An angle is made up of 2 rays with a common endpoint. Lots of the angles we talk about in trig are going to be made from something turning, rotating around. So what we have, the first side, the first ray, we call that the initial side of the angle. That's an I there. Initial side of the angle. Then if you take that and you rotate that in a counterclockwise direction, that's going to be that is going to be considered a positive angle measure. It's a positive rotation, positive direction. This is called the terminal side, where it stops or terminates at. This will be a positive angle measure. if you have your initial side, and you rotate clockwise, we're going to call that a negative angle measure. So the positive and negative are telling us the direction of the rotation. Yes?
Can I grab Ruby for a second?
Sure. So this one's going to terminate this way. So clockwise rotation gives us a negative angle measure. So there's something new for you. We never had negative angle measures back in geometry because we were always measuring angles inside triangles or hexagons or decagons. We were fine. Those were always positive for us. Now in trig, we're going to talk direction of rotation. So now we're going to have negative angle measures. Everybody good there? We got it? Okay. See if you remember your angle classifications. I'm going to give you an angle measure, or actually you're going to tell me the angle measure and its classification. You'll probably remember the classifications first. What kinds of angles did we have back in geometry? How could we label them? What categories, Adam? Acute. Acute. Start there. What qualifies an angle to be acute? Yes.
Less than 90 degrees.
It is less than 90. How far down does it go? Would 0 be an angle measure? What about a half? What about 0.1? Those are angle measures, real skinny ones. So what I'm trying to get you to tell me is greater than 0, but less than 90. So we'll use our little interval notation. So I've got my 0 degrees to 90 degrees, but I don't want to equal 0 and I don't want to equal 90. So what kind of end things am I going to put there? Which one? Squared or rounded? The rounded. Because I don't want to equal 0 and I don't want to equal 90 to be acute. Okay? Another kind of angle. Yep. Obtuse. What's our range there? Greater than 90. And? Very good. Staying under 180, so not including those endpoints. Another angle. Skylar. Right angle. And we only have one value there. And there's one more. Yeah.
Straight line.
Straight angle. Straight line, yep. Call it straight angle. Doesn't even make sense. A straight angle is a line 180 degrees. Okay? There's our angle classifications. This one's going to be our two special pair. If they come in a pair and they add up to a magic number, we had two categories there. Do you remember what those two categories were? A pair of angles that add up to a special number. There were two special. You got them?
Complementary.
And?
I don't know. I'm blanking.
Elijah?
Supplement.
Complementary, supplementary, so they come as a pair. Complementary, supplementary. What were the two magic numbers that they had to add up to? Anybody got those? Jimmer?
Complementary goes to, they have to add 90 degrees.
add up to 90. So I'll say A plus B equals 90. And supplementary added up to? Go ahead.
To 100.
Yep. So, these are pairs of angles. Okay, you're going to have a whole section in the book of setting up equations, and so I'm only going to do one of these because they're kind of straightforward. So you'll have something like this, where you set up your little algebra equation and solve away. This angle down here is 2x minus 5 degrees. This one is 7x plus 5 degrees. Can you find each angle measure there? So your goal is to look at the picture, find a relationship in there, and write an equation, do some algebra, solve it, and answer the question. So, what relationship do you see in here with these two angles? Are they equal to each other? What is it? Elijah?
Then, if you add them together, they equal to 90.
Because what do you see in here that you're supposed to remember from geometry? The little box, remember, means 90. So this one plus this one equals 90. All right, it's that simple. Add those two together, they should add up to 90 degrees. And then it's your algebra. You do the algebra, I'll do the algebra, we'll compare. So each angle is 10 degrees. What do you got to do? Adam?
Plug it back.
Yeah, plug it back in. All you did was solve for x. If I look back, these angle measures, those ones, 2 times the next value minus 5. Oh, okay. So that angle measure would be 15. This one's going to be 75. Don't forget to answer the question after you do all that algebra. 2 points here, 1 point here, minus 1 point there. If you don't give me that, you leave it at 10, you can finish the question, minus 1 over there. So make sure you answer the question. All right. Now, so there's your new stuff coming at you right now. Measuring angles. Okay, when you measure angles, we had our little protractor dealy right here. You know, we usually just measure it to the nearest whole degree. You know, maybe it was 38 degrees or 105 degrees or whatever. Do you think it's possible to get in between whole number degrees? Could I draw an angle that 10.5 degrees? Should I be able to do that? Or 100.6 degrees? Yes, well, when the Greeks that started this stuff, they decided to take an angle measure of 1 degree, which is very small, a little tiny angle, and they chose to break that up into 60 equal parts. Okay? Those 60 parts, they called minutes. So 1 degree can be broken up into 60 minutes. That little hash mark there is the word for minute. Then they said, well, we want to be even more accurate, because once you start making angles really big, like out to the moon and out to the sun, and it gets quite wide at the end. So then they took 1 minute. So imagine how small 1 minute is. So we're going to break that up into 60 equal parts. What do you think they call those? Seconds. So 1 minute got broken up into 60 seconds. So then tell me, how many seconds are there in 1 degree? If there's 60 minutes, and each one of those minutes is 60 seconds, how do I figure out how many seconds there are? 360? You're close. Yeah, 3,600, because you're taking the 60 minutes and multiplying by the 60 seconds, you got your 3,600 seconds. Okay, so now what you need to be able to do, because we're going to see these degrees and minutes and seconds all the way through the whole semester, is be able to do some math with them. If I asked you to add 47 degrees, 32 minutes, with 23 degrees, 45 minutes, could you do it? Add. Okay, very simple common sense. You're going to add your minutes to your minutes, your degrees to your degrees. Then if we need to do some simplifying, we will, which we will. So adding, how many minutes do I have here? Looks like 77. Over here, we got 70. 70 degrees, 77 minutes. Looks like a good answer? What's wrong with it? Grace? Right, because you've got a whole degree hidden over here, because 60 of these makes a degree, so you do want to simplify that and bring this down to a number always less than 60. So if we take off 60 minutes, we're going to add it back as 1 degree, just shifting them over. Just to show you what I'm doing there. So the real answer should be 71 degrees, 17 minutes. Okay. What about subtracting? 75 degrees, 10 minutes. Subtract off 18 degrees, 51 minutes. Okay, so again, it's minutes from minutes and degrees from degrees. Of course, we'll run into issues right off the bat. Can you take 51 minutes away from 10 minutes? No, what do we got to do? Go back to 2nd grade. Adam? Borrow. Is that where you learn to subtract, 2nd grade? Isn't it? I think so. Borrow. We got to borrow. What are we going to borrow? Go ahead.
I'm thinking we're going to borrow a degree.
We're going to borrow a degree, so we're going to bring this down to 74 degrees. What does it come over as? How many minutes is this 1 degree? 60. So I'm going to add 60 onto this, so I will be starting with 70. Everybody catch that? We borrowed 1 degree, but 1 degree is 60 minutes, so I add 60 to the 10 that I had. I'm actually starting with 70 minutes over here. Now I'll go ahead and subtract. So 51 off of 70 is 19. And 18 from 74 is 56. Okay. Very easy to do by hand, but do we have technology that works with degrees and minutes? We certainly do. Graphing calculators have it. Scientific, just the little scientific calculators have the ability to work with degrees, minutes, and seconds. And I just want to redo these 2 problems. You can decide. I don't care whether you do it by hand, but you're going to see how much button pushing it takes to type in one of these simple problems that would actually be quicker to do just by hand than to type it in. But I'll show you it exists, because we will have to use it at some point. Sounds like he's making his way that way. Oh, you see it?
Yeah.
Where is it?
It's by the box. It's at the end of the box.
Oh, there he... Oh, yeah. Just wait.
There's a crooked.
with him.
Oh, wow, that's better.
That's much better. Okay. Alright, we're gonna redo the first problem. So you just gotta know where your degree and minute marks are. So you put in your 47. And not all calculators are the same. Even if you have those scientifics, you're gonna look for either a little, I gotta find it somewhere on there. Can't remember where those are at, but you can find it. But for people with the graphing calculators, go into angle, which is in yellow. Otherwise, look for a little degree mark or tick mark on the scientific. And look at, you're gonna see the degree and the tick mark right there at 1 and 2. So 47 degrees, 32 minutes, plus 23 degrees, 45 minutes. Did you guys find it yet? Did you find your scientific
I
one?
think it's, yeah, it's like DRG.
That's your mode you're in. Nope, that's not going to be it. I'll come and find it afterwards, though. If you hit enter now, you're not going to get the answer that we have. We got the 71, but it's got a big old decimal. There's degrees in minutes, or you got the decimal degree here, which we don't want. Now you can just ask the calculator nicely to say, no, please give me degrees in minutes, and it will. Asking it nicely is, again, back in angle. Down to number 4, that DMS stands for degrees, minutes, and seconds. And that little triangle means convert. So convert my answer to degrees, minutes, seconds, there it is. Okay, now go ahead and try the second one, subtracting, and I'm going to get to the scientific people here.
It's right here.
Did you find it? Oh yeah, there it is, perfect. So you can get the answer. Well, come on. Did you find it? Yep. Did you find it? Everybody good? You didn't, did you find it?
Yeah.
Right. Oh, right here. Degrees, minutes, seconds. And then see if you can find that convert to degrees, minutes, seconds after. Finish that one off. Hooah! Over here.
What do you find, Rosie? Hey,
Hold it. There's your angle right there, degree.
get too deep. If I just would have looked at the name. Like the rest of it was pretty scary, and then there was that one where you But then when you have to like, instead of next week, you know what, yo, everything is so much more like a year older than
One pushing where I think we could do that much quicker, right? Was there anything else I need to get to? Anybody? Good? Okay. I think it's quicker to do it by hand than at this point.
So I guess are we gonna have to deal with seconds too?
Oh yeah, that's coming.
I got the biggest.
I should do one of those right now too. Let's go 18 degrees, 25 minutes, 32 seconds. Okay, we can add by hand, which we're going to do. And then I'll show you where the seconds is on the calculator. So what do we got here? 47 seconds, 27 minutes, 303. To me, much quicker to do that by hand than it's going to be for us to go back in and type those three values in. But, again, you still need to know where they're at eventually. So, the seconds mark, keep going, this way, still follow along. The seconds mark on the graphing calculator is the green quotation. So to get anything in green, obviously you got to hit the green key. So again, the default is always decimal. So now to get that degrees, minutes, seconds back, go back in, convert to DMS, and there's our answer. Calculator skills are good? Okay. What else we can do? Okay. Next thing I want you to be able to do, by hand and with the calculator, is to convert we are. Convert decimal degrees to degrees, minutes, and seconds. Okay. Start with some common sense. Let's come up with our process we're going to use when they're ugly. if I had an angle that measured out to be 45.5 degrees, I would like to know how many degrees and minutes that is. Well, I can see I've got 45 degrees. Then I've got a half of a degree. Well, how many minutes would a half a degree be? Simple. 30, right? So the full one is 60. What's our process mathematically going to be when I put something there that's not so obvious, like a 0.8 or a 0.862? What can we do? Adam? No?
Don't you just like multiply 60 by 0.8?
Yeah. You're going to multiply 60 by your decimal. So to get this part, you're going to take the decimal of 0.5, multiply by 60. That's what's giving us our 30. So you just take your decimal and multiply by 60. And I'll show you the calculator. Well, you already know the calculator, really. 26.25 degrees. So again, you know your degrees are 26 degrees. And now I've got 0.25. I just have to multiply that by 60 to see, well, what's a quarter of 60 going to turn out to be? $15. And we'll try one more. 100.3 degrees. So again, you got your 100, and then whatever 0.3 times 60 would be. 18. So, there's by hand, simple enough. By calculator, all you gotta do is type it in. I'll do that last one. 100.3. Oh yeah. Do I need the degree mark? That's the question. We're gonna find out. I'm gonna try it without it. I'm just gonna say convert to DMS. I didn't need to put the degree in. Degrees. Oh, look at what happened when I did. Okay. I know why this is happening, because my mode, I'm going to bet when I hit mode, I'm going to be in radian mode. And there I am. The third line down is radian mode. You don't know anything about radians yet, because we're not in chapter 3. So you're going to want to check your mode right now. Make sure you're in degree mode. Press your mode or find your mode. You want to be in degree mode. The scientific calculators, you'll have a little D or an R showing on your screen all the time. Or you could check and see what I did. If you do 100.3 degrees and you do that DMS thing, if you get that, what you obviously know is wrong, 1 degree, 45 minutes, 2 point whatever seconds, you're in radian mode. You gotta switch it out of that for now. Okay, can you go backwards? Can I give you degrees in minutes and seconds and convert back to decimal? Start simple again. 86 degrees, 30 minutes. Okay, 30 minutes. What decimal part or fractional part of a degree is it, Adam? It's a half, so we're going to put in 0.5. Now what's our mathematical process we're going to do when this is not so obvious that it's exactly a half?
Take that number and divide it by 60.
Take that number, I've got 30 minutes, and we'll divide by 60 and see what decimal we get. So it's going to be a divide. So if I had 15 degrees, 25 minutes, we need to take 25, divide by 60 to see what decimal that is. Not that I have a clue what that is. 25 divided by 60? Ooh. And I think when this happens, it says to go to the nearest thousandth. So we would be putting down 15.417 degrees. Pretty sure it's thousandth if I remember from the last 15 years of teaching this, or longer. What about the seconds? I kind of lost those. 172 degrees, 45 minutes, 32 seconds. What's going to happen here? You got the 45 out of 60. But what about the 32 seconds? What part of a degree is that again? How many of those seconds did it take to make a full degree? Do you remember from the beginning? 3,600. So that's what you've got to do, is take that 32, divide by 3,600, and then you're going to add those two decimals together. So we got 0.759. So there's the math to do those. Again, the only reason we crank through that, because that's a little bit obnoxious, is for SAT purposes, because there will be a no calculator section. Okay? And if this stuff comes up, you have to know how to do that. So how do you do it if it's on the calculator section? Well, you just type it in the way you see it. 172 degrees, 45 minutes, 32 seconds. And all you gotta do is hit enter, because the default is decimals. Hit enter. Oh, there it is. Let me see if I want to stop there or finish this up. I got one more thing, but we'll see how long tomorrow is. Oh, do I do this or not? I think I'll... This goes... Yeah, I'm going to do it. Dang. Okay. All right. Coterminal angle. Yeah, because this one we want to hit 2 days because people, I don't know, don't get this, I guess. Coterminal angles. Co, together, like co-workers, or workers that, people that all work at the same place. Coterminal angles. Remember the terminal side of an angle. The terminal side is where it stops. It starts at the initial, terminates somewhere. So these angles have the same terminal angle, but they have different angle measures. How's that going to happen? So angles that have the same initial side, so they start at the same spot, and the same terminal side, so they stop at the same spot, but they have different angle measures. So they start at the same spot, they stop at the same spot, but they have different angle measures at the end. Those are coterminal angles. So, we're going to put them on a coordinate plane so it's easy to see. Our initial side is going to be the positive x-axis. That's going to be our 0 degree mark. I'm going to make a 45 degree angle by rotating that thing in the positive 45 degree. So if I go up, that's halfway in the first quadrant. Here's my terminal side. So my first angle is going to be 45 degrees. Now I want at least 3 more angles coterminal to that. How do I find those angles? How can I create another angle that starts here and ends up stopping here, but it has a different measure? What are you thinking? Can I go backwards? Can I start here, spin around this way, and stop here? Did I meet the criteria of starting in the same spot and stopping in the same spot? Okay, so we can show that with our little arrow. So that's a negative angle measure. How many negative degrees is that? How do we get that? What are you doing to figure that out? What's the full rotation? 360, but we're not going this last 45. So what's 45 off of 360? 315. So a negative 315. Okay. I want another one coterminal to 45. So start here, stop here, but has a different measure. Yes.
I don't know if you can do this, can you just wrap around another time and have it be like 4 or 5?
Okay, so you're saying, I just got to blow by this, and then stop there again. Did I start at the same spot and stop at the same spot? So, we're going to show that, blow by it, this is a phrase, nice, and then stop the second time around. How do we figure that out? What did you do to figure that out? Add 360 to the 45. Because it was a positive direction. That's 405. So we've got 3. Give me one more. Coterminal at 45 degrees. What else can we do? I'm running out of colors. This will be the last thing we do. Go around again. Blow by at 1. There's the 405. I'm going to blow by it again. Getting messed up. So all I've got to do is I went another full rotation around this one. That's going to be a 5, 6, 765. So in essence, what do we need to do? Just keep adding 360s to this 45. Or subtract 360 from the 45. Go, go, go. Okay, I'm going to stop there. Well, actually, write the equation. 45 plus 360n, where n is an integer, will generate all of them. Because if we put a 2 in there, that's saying add 360 2 times. If I put a 3 in there, that's saying add 360 3 times. Or a 4. Or a negative 1 would be a negative 1. Would be subtracting 360 once from it. Negative 2 would be going backwards twice. So there's an expression that will give you all of those. Alright, now I'm done. Page 21.